All right, folks, now we have the quadratic negative x squared minus 14x plus 1. Okay? In this case, our leading coefficient is not a pretty positive 1, is it? Okay? It's negative 1. It could be a 2 there, it could be a 3. The process is still the same, okay? All right? We ready to proceed? All right. Whatever your leading coefficient is, if it's not the pretty 1, all right, you're going to factor it out. Okay, so let's start by factoring out. What's my leading coefficient again? Negative 1. Let's factor it out, okay? So once I factor out a negative 1, what's left behind? What can I multiply by negative 1 to get a negative x squared? Yeah, a positive x squared, right? What can I multiply by negative 1 to get a negative 14x? A positive 14x, right? And what can I multiply by negative 1 to get a positive 1? Very good, a negative 1. So far, so good? Okay. All right, folks. So now we have what looks like normal inside of these parentheses, don't we? Okay? So we're going to go through the motions, but we're going to have to put a double set of parentheses here because we have to accommodate this negative 1 throughout the entire problem. Okay? Watch this. I'm going to have a negative 1. Okay? Parenthesis, parenthesis. Open parenthesis, open parenthesis. Okay? And I'm setting up the problem like normal. I have x squared plus 14x. I leave a space, right? And then I have my minus 1. But I'm not going to close the parentheses without leaving a space. I got to leave a space for what's going to happen later, okay? How are we feeling so far? It's a little funky.
Notes the reason for the double parentheses. If you don't write like a note to yourself why the double, it's not going to make sense. You have to write your notes that make sense for you. Because if you just wrote what's up there, you don't know the reason for it. You have to write the reason for those double parentheses. That's the only way to make sense when you turn back and look at it.
Yes, Torrin? All right, I'll say it again. You see this negative 1? Okay? We have to accommodate for the negative 1 throughout the entire process. We're going to be doing things with this negative 1 at the very end. Okay? And because I have something on the outside, you see this set of parentheses right here? That's the only thing that's different. Think of it as protection. I'm protecting the process from the negative 1 until I get to the end. You understand what I'm saying? Because if that negative 1 wasn't there, I'd be working out this problem like normal, wouldn't I? Right? Okay? So it's like we're putting up a fence. Let me handle business inside the parentheses until I can take care of the negative 1. All right? May we proceed? Okay. Now, like normal, I take my B term and do what? So I'm coming over here to my margin. 14 divided by 2 equals 7. Okay? And now remember that 7 is special, y'all. What does that 7 represent? The factor. Who said the factor? Who said that? The factor. Who was it? It was you, Mikhail. Thank you very much. Not bad for somebody who missed out on class yesterday. Bless the children. All right. So now I take that 7 and do what? And that equals 49. And what do I do with that 49? I add it here. And I subtract it here. So far, so good? Okay. So technically, we're done with the completing of the square, right? So the factorization of my perfect square trinomial here is going to be what? Let me draw my line. So I'm rewriting this. I still got to deal with the negative 1, y'all, okay? Okay. So what's my factorization? The quantity of x plus 7 squared, right? And then what is this equal to? Okay. So minus 50, right? All right. Now it's time to deal with that negative 1. You ready? Oh, wait. Let's see some of y'all right now. You ready? So you take that negative 1, y'all, and I'm going to multiply it to each of these terms individually. Check this out. This is one term. This is one term. Do you see it? Okay. So negative 1 times this quantity is simply going to be negative 1. Excuse me. I'm not going to put a 1 anymore. Negative 1 times the quantity of x plus 7 squared, okay? See that? And then you see this negative 1 again? I got to multiply by this negative 50. What do I get? Yeah, positive 50, right? So I'm just going to say plus 50. And boom, she's done. Talk to me. Did I add? When you see a number, excuse me, when you see a number in front of a set of parentheses, what operation do we always use? Multiplication. We distribute using multiplication, right? So we said negative 1 times this quantity and negative 1 times this quantity, okay? Negative 1 times this is going to be negative, or the opposite of the quantity of x plus 7 squared. And negative 1 times a negative 50 is a positive 50. Talk to me. Hello? How we feeling? What's the A value of this quadratic? I beg your pardon? Negative 1. What is this parabola going to do? It's going to point down, right? Let me draw an ugly representation of this. Oh, wait. Help me out. What's my vertex? Negative 7 and 50, right? All right, let's do it. Okay. Here's negative 7. Here's 50. Okay, y'all, this graph is not drawn to scale, okay? My vertex will be located here. Y'all told me my vertex, my parabola is going to be doing what? Yeah. Don't be a hater. Okay? So does this have a minimum value or a maximum value? Why? Because it's the furthest it'll go up. It's the highest point. It kind of looks like a little old ugly mountain, right? Mountains have peaks. They have highest points, right? Okay? So when your parabola is pointing down, you have a maximum value. Okay? Maximum value. And the maximum value will be simply whatever your y value is in your vertex, or whatever number sits right here. So we have a maximum value where, baby? At 50. At positive 50. That's it. Once you really, I don't have to draw a picture, right? If I understand what the vertex form is telling me, okay? And really the x value is of no consequence. It's all about the number that sits right here. If they give you an equation, if I gave you an equation, y'all, if I just said, okay, y equals negative x minus 7 squared plus 81. Oh, sorry. What is the minimum or maximum value of this quadratic? You would just say 81? I mean, 81 it's an answer, but I said, what is the minimum or maximum value of this quadratic? Which one? Why? Because it's pointed downward. And what else? Come on, talk to me. How do you know it's pointed downward? The A is negative, okay? Therefore, there's going to be a peak, there's going to be a highest point, and the highest point is going to be whatever number sits here. Does that make sense? Okay? So it's going to be a max at 81. If I gave you this one, y equals x plus 3 squared minus 7. What would you tell me? Minimum at -7. Bam. How we feeling? Make sense? But that's if they gave it to you in Vertex. Sometimes you might have to put it in Vertex form. Okay? We good? All right, everybody go to the class website. Everybody go to the class website. Oh, sorry, y'all. Let me stop this.